All right, we can start.
Okay. So on behalf of SPE Ghana session officers and leaders, we want to welcome everybody to today's technical session. And at least for those with a technical background, I strongly believe the understanding in developing new case tubing technologies is something that is worth knowing. I believe one of the first objectives of SPE is knowledge sharing. And that is what SPE Ghana has been doing in the past years, ever since it was, ever since inception. And today we have no other person than Tan and John, whom I know virtually. And I believe that they can make justice to this topic. It's quite unfortunate. I have personally left the technical, let me say, scene. I'm now doing more of commercial stuff, but I'll stay tuned and learn something new. I believe when RSS came back, came into the system. Most of us at that time were so much in depth in new field development. We're very excited, and I want to see those excitement in the eyes of the drilling engineers and even the production engineers right here in Ghana, and for those who are from Nigeria or other African region who have joined us. So we want to welcome everybody to this monthly technical meeting, and what I can say is enjoy having a new understanding in the business that you do in. So welcome once again, John, and then my very good friend Tan, and thank you for making this happen. We're looking forward for several collaborations like this. Thank you so much.
Thank you very, very much, Dr. Riverson, for opening remarks. For this particular presentation, this month's technical session, we're going to look at, like Dr. Riverson said, we're going to look at new developments in casing tubing technologies. And we've got experts from Valorec Tubes that are going to lead this discussion. To give a brief overview of what we're going to talk about, we're going to look at developments in casing and tubing technologies that will help oil and gas operators in drilling and completion operations. And these services that are provided by Valorec that are in tune towards this in terms of prime mapping, yard services during preparation for packer, cementing, or even drilling operations. Also in terms of tubular repurposing services provided by Valorec to enable operators rerun redundant pipes so that they can also focus on inactive or put out pipes. And then finally, our experts are going to lead us in discussing pre-installed cable protector solutions, how these are also being used to reduce protector installation time on the rig floor. So, our experts are going to lead us in discussing these developments and how they are going to help operators to manage rig floor time, reduce hazards, and also reduce human errors while enhancing well performance. So without much ado, I'd like to also introduce our able experts. We've got TB Nguyen, who has joined Valorec in 2019 as Innovation and Corporate Strategy and Marketing intern. That was during her master's degree program at IFP, where after her internship, she continued to work for Valorec as OCTG Services Project Manager. But before that, she also worked with Schlumberger in the drilling and management domain from 2010 to 2017. Together with TB, we have John. John BB works with Valorec as a Services Business Development Manager for OCTG Services Business Development Manager for pre-installed cable protectors. He has over about 10 years experience in completions with particular focus in permanent downhole monitoring using fiber optic and electronic sensing systems. John worked for SPE Group, Baker Hughes, Century Lift, Weatherford International, Completion Products Limited, and in all, he has been focusing on permanent downhole monitoring. So, as has already been said, we've got experts to do justice to this topic we're going to deal with, that is new development in casing tubing technologies. Without further ado, please, I would like to welcome TB and then John to give us a discussion for this session.
Thank you, Alex. I will introduce myself a bit first and we'll do a short presentation and then hand over to John with his presentation, and we take the question at the end of the session if it's okay for you. Okay, so to start, I type my name in the chat with the company name and my work domain, and I encourage you to do the same. So that will help us to understand your background and answer your question better. So do not hesitate to open the chat box, type your name, your company, your work position or domain, and where you are from. I will share my screen. I don't know, John, if you want to say a few words before I start.
Oh, I think it's okay. I'll just introduce myself before I start my section.
Okay, thank you. Share the screen. I hope you all see my screen. I'm going to go to full screen mode. Okay. So the first topic, one of the first of the two is price mapping is the name of the service. Basically, it is mapping to obtain the casing tubing actual data from surface, so in a yard on the rig deck, to help the downhole operation performance. So you are all in the oil and gas industry, or we call energy industry. We know that it's quite old school. So we do not have much of robotics or digital or fancy technologies that other industry has. So this is just a bit of improvement on our conventional drilling completion operation to help the operators. Standard slide from Valorex. Basically, we are casing tubing manufacturer that we provide pipe from several countries in the world, and we have about 20,000 employees everywhere. We do sell pipe, but we also have services, including VAM fuel service and service for the new energies, mean that geothermal, hydrogen, and CCA, etc. So in the scope of services that I present today, we develop it from the ideas in the garage that may be similar to some of the ideas you have in your free time. Basically, we listen to the operators and we see that they have several problems that relate to casing. For example, packer setting cannot set, or packer leaking. Cement displacement is not good. The plugs didn't bump. Pipe have the burst and collapse concern because the collapse risk is too high in that formation downhole. Or after a while running downhole or staying in the surface in the yard, pipe get corroded and get some defect. So all of these problems inspire us to find a solution. And the solution is the robot that I'm going to present you right after this. The solution is a price mapping service empowered by in-pipe rover device. So in-pipe rover is a portable device that a technician can carry with him to the rig or to the yard in the back of the car, the pickup truck, or we ship it from one country to the other and to perform the job. It's pretty light. It's 18, 19 kilogram. So you need a strong man to carry this. Basically, this device will go to the pipe from one end to the other, come back, and then deliver wirelessly the geometrical dimension like ID, OD, and wall thickness, and then calculate ovality, eccentricity, outer roundness, bore volume, metal volume, etc. So from all of this data of one string that before we run in hole, we will segregate the casing and optimize the string before running hole. And this action makes sense for the packer setting, for the cement displacement, for the casing wear mitigation, and for the downhole collapse mitigation. Okay, so this is a video to show you the in-pipe rover device. This is a laser device using laser technology. So the device will turn the laser, will scan the pipe body. It will read internal diameter, ID, and also a small encoder on one of the wheel, read the pipe length. And from one end to the other, it will detect the pipe end, and here it will slow down. You see it will slow down and track back. So you don't need a person standing on this side. You only need a person on the other side to send the rover inside and receive it and move it to the next pipe. So this is the kind of mapping or logging technology that will acquire pipe information that makes sense for drilling and completion. And from this data, we will segregate, we will optimize the string to select the best pipe for packer setting, and to calculate the bore volume for the cement displacement, and also optimize the string to place the thicker pipe at the critical section. So I hope that you all have some drilling and completion background. You know what is the packer, right? So if you want to set the packer downhole, you need that the packer first is small enough to go inside the casing or tubing casing. And then the packer will expand and fit to the internal surface of the casing. And that is critical if you check the packer OD at the open position, fit to the casing ID. So normally the operator check the packer very carefully, choose the best one, the most routed. But sometimes we forget to check the casing ID, and we take the default number from the book. But as the manufacturer of casing, we know that the number from the book very generous. So it has some certain inaccuracy that we better check from surface to ensure that whatever we send downhole will fit. So this case, packer and casing. The second application is bore volume, because you see that the rover acquire ID and length. We can calculate bore volume immediately and then accumulate this number for the string volume. And that is and that bore volume is equal to the volume of mud that you need to displace the cement when you have a cement displacement job. And that would help you to have a cement plug bumps. And when the driller often say, I need to bump my plug, this is the formula behind. If you want to bump the plug, you need to pump the correct amount of mud to push the cement from the internal side of the pipe to the external, to the annulus. Okay. The third application of the in-pipe rover or prime mapping service in the yard is to manage all the pipe with data and then choose the thickest one for the critical section. Critical section mean high casing wear or high burst and collapse risk. So sometimes you even want to recalculate your burst and collapse rate according to this actual data. Because when the drilling engineer designed the well, you only do this calculation with a nominal number. You don't have the actual number at the time. And you take the worst case. But sometimes it's difficult to calculate this for the whole string because the string will be in contact with several formation layers. So some formation is more difficult than the others to deal with. You may want to optimize the casing string according to this. Okay, so some job we do in the world, we want to share with you that this service is not very old, it's new, but we have been running it for Total, for Shell, for Neptune Energy, for Shell Gas, Shell Oil operator in the US, in Abu Dhabi, in Brazil. So several sites, several clients, several environments, both onshore and offshore. It proves that this small service is helpful for the operators. And if I have some drilling engineer, completion engineer in the room, I think you will agree with me that we should always check, double check or triple check everything, actual dimension before sending anything downhole. So the secret behind the laser in-pipe rover, we have 3 types of rover. We have a laser, we have ultrasound and eddy current. So the same principle, but changing technology. Basically, we have a portable, we have a laser head that have 2 laser sensor, like you can see in the pictures. It located at the front and back, and then it will rotate and scan for internal diameter. So while the device is moving self-propel inside the pipe, the laser head will acquire data and send it wirelessly to the laptop nearby. Okay. This is the job. So the engineer log in the laptop to see the data if it's good or bad. The software interface is like on the right side at bottom. You see the pipe profile, so digital profile in terms of ID. And if you already talk to the completion engineer to know the packer threshold, like my packer should be should fit to the pipe from 8.4 to 8.6 inch, for example. Then you check all the pipe ID full length, and if your pipe have 8.7, you reject this pipe for packer. You only select the one that fit the packer setting range. Also, the second criteria is ovality. If you want to set packer on one pipe, you may want to choose the pipe that is the most rounded inside. So ovality or outer roundness, internal is calculated from the internal diameter map. And then with all this information for every single joint, you have a pre-job, pre-run tally. So the tally won't be marked like this one is good for packer, the other pipe not for packer. And then beside the column of OD or length, you have another column of ID and bore volume, so that you can enhance the tally for the driller, so the driller know how much he need to pump. Okay, so that's it for my first presentation. I think I'm on time for this, about 10 minutes. I will go to the second presentation, and do not hesitate to put on your name, your company, your background in the chat box. Also, any question you may have, put in the chat box. We take time to answer. The second technology that I would like to share with you is tubular repurposing. Run unused pipe or sell them even work over pipe. Why we have this business? Because in oil and gas is a tradition that we buy the pipe, we buy a bit extra, we buy 110% normally, and then we run in whole 100, and then 10 is left over in the yard and normally forgotten. There are many surplus pipe laying in the yard here and there. Second case, we do a lot of work over. So pipe running in hole or in the sea, like a riser running in the sea, and pull on the surface. Sometimes we do not have a good quality assessment method to say that if the pipe is still good, can I run in hole one more time, or I should stop this pipe and bring back to the repair shop. So the service is developed to answer to those questions, and then we can resell the pipe online if we want to. So again, standard slide to say that Vallourec, as a casing tubing manufacturer, we care a lot on sustainable development in manufacturing. But now the next step is to care about sustainable development in well operation. It means that the operator should use the pipe in the sustainable way and do not just buy a lot and waste a lot. So this slide I already tell you before, we deal with the fourth aspect, corrosion and metal loss, how to evaluate them, how to assess them, especially on the inactive and workover pipe. We know that for the brand new pipe, the manufacturer gives you all the materials according to API 5CT, but it's hard when we deal with the stock that is not brand new. It's gray zone that there's no standard. So on the left side, we see the tubular supply chain today. We do manufacturing the steel, rolling, heat treat, and threading. And in the yard is where the pipe manufacturer like Vallourec, like Tenaris, like Nippon Steel, Sumitomo, hand it over to operator like Tullow, like Total. And then part of it, let's say 100 pipe go in hole, and then part of it, the smaller part, stay left over or used in work over operation. But these parts receive much less care, and it accumulates over the years. And at the end, when we don't know what to do with it, we send it to scrap. So my message today is, before sending it to scrap, let's do a pipe assessment to tell if some of them can be potentially reused. And then we only scrap the pipe that are really bad. Okay, so to do that, we check the pipe condition. We have in Vallourec, we have a big NDT team. NDT stands for non-destructive testing. So they know everything about the pipe. They can tell the pipe quality very well without destroy the pipe. So you see the new pipe look like this, brand new, clean, all the information is printed, everything is clear, very organized. But after a few years become like this. Then here we never can be sure if we can use the pipe or not. And believe or not, just some rain and some, sea humidity can cause this situation. Some pipe look really rusty, but actually they are good. So by the bare eyes, you cannot tell. You need a better assessment method. Here is the case that the pipe get a bit damaged due to the downhole impact. The pipe that run in hole, exposed to the mud, to the production, to the casing wear, to the wine line. So it could be a wine line cut, it could be casing wear, it could be galling or pitted. Okay, so all of these defects need to be checked. So we have in-pipe rover solution again, but serving another service called tubular repurposing. And why we say it? Because repurposing means we have two options. Either you don't want them anymore, you put them on sale. And normally it applies for the pipe that haven't run in whole yet. So if the pipe are still unused, just exposed to the weather impact, you can sell them. And if your pipe are already used, normally we recommend you to reuse them in the well, another well with lower spec, repair them, and if it's really bad, scrap them. So 3 levels of inspection. First is visual inspection, and using some manual gauge. Like this man is checking the wall thickness of this spot. The second level is we go with automatic dimensional inspection. Like the laser rover I showed you the video before, it will give you all the ID wall thickness, OD mapping. And then the third level here is the advanced on-site entity, where we can do the defect map. We can tell this pipe have some oblique crack, the other one have longitudinal or transfer crack, or some pipe have pitting. So we know what to do with the pipe. Okay, so similar to the laser rover that I introduced you before, here is the ultrasound and eddy current rover. The principle is the same. We change the sensors, the ultrasound part, but ultrasound need to run in water. So you see, there's somebody that creates some noise. So if possible, please mute your side so that the background noise will not affect the people. Thank you. So these 2 orange bearing can contain the water inside. So this water column will move along the pipe with the sensor inside, and then it will give you the wall thickness mapping. The one below is equipped with eddy current sensor. It will have the current run on the pipe internal surface, and here we can detect pitting, cracked very accurately. Okay, so here's a bit of illustration how the defect map and wall thickness map look like. The NDT expert will tell you this pipe is still good, the other pipe have some crack at pipe end, go and cut and rethread. The other one have too many defect, and you should reject and scrap it. So advice like that is valuable for the operators. And then like I mentioned before, sometimes you want to inspect the pipe to make sure that they are still good, but then you want to post them on sale. And I know that there are many small traders is active in Ghana and other West African countries. So instead of working with all the small traders, you can post them online on the platform. Doesn't matter if it's Valrec pipe or Tenaris or whoever pipe. If you have enough information, if you have inspection certificate, you can post them here and even tell the price. And you never know, sometime another operator in Angola, in Nigeria, or in another town in Ghana may be interested in buying them for their well. Okay, so not just pipe, all the completion equipment, bearing, all the float equipment, etc. And any manufacturer, you can post the item here. So this is to share with you that nowadays equipment trading is much easier than before. You have a third party to inspect the pipe for you, and you have a platform so that you can dispose them smart way. So just a bit of story before I finish my presentation. We have a client in Brazil that they need some special joint to run inside salt formation below the post salt. So the whole string 14-inch is not thick enough for this salt layer. So what we do is, instead of asking them to order 50 joint of thicker pipe, we look in their yard and we find for them among 50 joints, 36 joint was thick enough to run inside salt. So the operator, the IOC, is very happy because they don't have to spend 8 months and extra 150,000 to buy 50 new pipe, thicker pipe. So it's a great saving of cost and time. And they're very happy with it. A small robot that run inside the pipe and give them information. So here I finished my presentation. I will hand it over to John before we receive any question.
Thank you very much, Bin. I will now do my presentation. Okay. There we go. Share. I hope you can all see the screen. Are you seeing the start of the presentation?
Yes, please.
Excellent. I'll start it now. Okay. So just to introduce myself, I know Alexander mentioned my background. Just to confirm, I've had 10 to 20 years of permanent monitoring installation. So that's putting a pressure gauge, a temperature gauge, or a flow meter down at the bottom of tubings being installed in completions around the globe. So for those installations, you need cable protectors. So completion operation today, as I've said, you need cable protectors when you install these downhole pressure gauges, chemical injection mandrels, sliding sleeves, or safety valves. They all have lines, either data cables or control lines running from them back up to the tubing hanger. So you need cross-coupling cable protectors to support and protect those cables and control lines. Traditionally, these cable protectors are installed on the rig floor during running hole operations, so you're taking valuable rig time to manually install these cable protectors. And you typically need several people and several tools being used in the red zone around the rotary table to complete that operation. And there's also logistics. You have to ship multiple crates of cable protectors to the well site and up to the rig floor, which can further delay running hole operations. So to start with, I've got a short video here showing a traditional cable protector installation, as you'll probably see today. Here we have a Halliburton engineer holding the gauge cable. He's waiting for the power tongs to be retracted, and then you'll see various rig crew who will be helping him out. This gentleman in the orange and the back braces will pick up a manual, an automatic air gun, I should say, to make up the two bolts. Now the Halliburton hand here, he's just picked up a traditional cable protector, which I think you can see has got a main body and two collars. Now, each of those collars, one at the top and one at the bottom, will have a bolt and nut associated with it. Now you've got a second rig hand here who's holding the cable. He will eventually be pushing that cable up against the tubing to make it parallel, so it's easier to install the cable protector. And this third rig hand here, standing at the moment, he will shortly pick up the manual torque wrench to tighten up the two bolts. So there now, the one rig hand is holding the cable. The Halliburton engineer is trying to install the cable protector across the coupling and around the tubing. Sometimes it can be difficult to engage the collars. So on this occasion, the Weatherford hand has brought along a lever to try and encourage those collars around. It's not actually needed for this particular installation, but we're getting to the point where the one rig hand is now tightening the bolts with his air gun. And he doesn't physically tighten them up to the correct torque value, but it's just to get them made up so that they cannot slip out. And then he's done those two bolts, and now I've got the final rig hand with the manual torque wrench to tighten up. Oh, he slipped a little bit there. So he starts play acting, but he's tightening the top bolt to a set torque value, which is normally 30 foot-pounds. And he now moves down to the bottom bolt, and he's tightened that one up as well. So as you can see, that's taken roughly 2 minutes to install one cable protector. So to summarize that, you have 5 personnel were needed in the red zone around the rotary table with up to 3 tools plus air hoses powering the pneumatic air gun for 2 minutes on this occasion. Sometimes it can be quicker, but more often than not, it can take even longer than 2 minutes to install a cable protector. And that was all just for one cable protector. Plus, there were numerous crates, such as you'll see on the bottom left here, that have to be shipped to the rig site. And there's regular lifting of fresh crates to the rig floor. So when you've got the crane operating, bringing these crates through the V-door, you can't really run in whole because it's dangerous to have crane movement around the cable and the tubulars. So with Valorex's pre-installed cable protector, all the above issues are greatly reduced or they are eliminated altogether. So what does our pre-installed cable protector look like? This is what the prototype version looks like, then the version that we've been using. It has 3 major components: a lower ring, an upper ring, and a shell, strap, and lever assembly. All these components are pre-installed on the tubing offline. That is done in the pipe yard. It can be done on the pipe deck on the rig, but our recommendation is to do it in the pipe yard where you have much more less time pressure pushing on you. When you do get to the rig, there's no change to standard pipe handling, lifting and running operations. Side door or slip elevators can still be used. There's no change to power tong handling. The power tong jaws can easily straddle the cable protector and grip plain pipe to plain pipe. And it's quick and safe to install the cable and secure it on the drill floor. The technical and mechanical performances of our cable protector exceed the market standards. As I'm sure some of you are aware, there are no industry-wide specifications for cable protectors, but several major operators such as Equinor, Petrobras, ADNOC have their own specifications for cable protectors, and our units have been designed to pass all their requirements. And on this note, it is a Valrex patented concept that we are demonstrating. So how do we pre-install the cable protectors? Well, first of all, if you remember, there were 3 components: a lower ring, an upper ring, and a shell assembly. Firstly, you take the lower ring and slide it along the pipe. Now, they're just doing it on a pup joint in this video, but the principle is exactly the same for full tubing joints. Obviously, for a full tubing joint, one workshop operator cannot lift the joint, but many rig prep facilities will have staggered trestles so that you can roll the tubing from side to side to let that ring slide all the way to the top. You then remove the upper thread protector and install the upper ring over the coupling. And you then bring the shell and strap assembly, place it to interlock with those 2 rings. You then bring the strap and bolt around, and the bolt nut will latch behind a retaining lug, which you'll be able to see shortly. And that lug is part of the shell assembly. So it's latched in there in place. You then take a torque wrench and tighten it up to a pre-arranged value to just keep it in place so it can't detach from the lug during transportation. Now, from the jobs that we have been doing so far, most of the rig prep companies who have been installing these for us say it's easier doing this than installing casing centralizers. So following pre-installation, you can ship the tubulars to well sites in frames or in bundles. There's no issue at all. And when you do get to the rig floor, you'll see here on the right-hand side, there are 1, 2, 3, 4, 5 joints of tubing on the catwalk waiting to be picked up. The first joint has actually got the single joint elevators already in place, picking up the joint. And so in this instance, the elevators are butted up against the cable protector, which in turn butts up against the coupling. So the full weight of that joint is being transferred through the cable protector to the elevators. Then when you get to the rig floor, here we have the 100-ton elevators lifting the whole string around the tubing. And again, there's no issue with these elevators. They can easily fit around the pipe and butt up against the bottom of the cable protector. So the full string weight is being transferred through the cable protector to those elevators. In this instance, there was approximately 3,000 meters of tubing below this joint, and the weight indicator on the drill floor was showing approximately 60 tons. So all that weight is being transferred through the cable protector, and they are rated to equal or exceed the load value of the coupling. And you'll note on the right-hand side, the next joint is in the mouse hole with a cable protector on top, which is just waiting to be picked up for the next stage. Once that joint has been run in hole, you then we have also invented a new 3D stabbing guide to assist in the cable protector use. The stabbing guide itself is 3D printed from a tough plastic, and it's easy to install. And you can also use it to rotate the cable protector to align it with the cables. Because these units are pre-installed, you don't know where that cable slot on the cable protector is going to face until that joint has been torqued into the tubing string below it. So you do have to rotate the cable protector to align it with the cable. But as you can see, using the stabbing guide, it's very easy to achieve that. And stabbing in the next joint of tubing, again, there's no difference to normal operations. And the guide is easy to remove. Then for the power tongs, as I mentioned before, there is no issue with the power tongs. They can easily straddle the cable protector, and they will grip upper jaws on plain pipe and lower jaws on plain pipe to allow that upper joint to be torqued into the string. Then the final task you need to do is to open the lever, push the cable in place, and close the lever. And then the one operator, this can all be achieved by one person, the one operator can then take either a manual or a pneumatic torque wrench and tighten up that single bolt. And it's done. So no tools were needed to install the cable and to lock the cable in place. And it's quick and easy, although he's talking to the driller at this point, which has slowed him down somewhat. And all the parts of the cable protector are captive and cannot fall. And you can secure just a single bolt with just one tool and one operator, as opposed to the video we saw at the very start where there were 5 people needed and 3 tools. So once the cable protector has been fully energized and locked in place, you then have to run through the rotary table as normal. So just as another brief video here, all the previous videos were from actual use of the cable protector. This one I'm showing now is of a trial that we undertook several months ago at a demonstration. And again, you see the single VAM engineer on this occasion. They're wrapping the debris skirt around the tubing as a precaution, which would happen in every case. He then rotates the cable protector, opens the lever, pushes the 2 cables in place, snaps the lever shut, and he wanders off screen just to get the manual torque wrench on this case. And with just a few quick strokes of the torque wrench, it's locked in place. So comparing our pre-installed cable protector to a traditional cable protector, traditional units, as we saw earlier, had 3, 4 or more operators needed for one unit. With Valorec, you just need one person. The traditional units use 2 or more tools to lock them in place. For Valorec's pre-installed cable protector, you just need one tool. Traditional units have 2 bolts. Valorec's unit only has 1 bolt. Traditional units take 1, 2, 3, and sometimes more minutes on the time-critical path on the rig floor. With Valorec, you just need maybe 10, 15 seconds. So the added value that we can bring to your operations, faster operations, rig time savings with faster operations, much fewer people in the red zone, so you get safer operations, reduced rig floor logistics and 0 manual handling on the rig floor, so you have simpler operations. And because you're saving time, your CO2 footprint is reduced, so you have cleaner operations. So pre-installed cable protectors can bring you faster, simpler, cleaner, and safer running hole. So just as a brief summary, is a short promotional video. So using Valorec's pre-installed cable protector, pre-install it on the tubing in the pipe yard. All parts are captive and cannot fall. And once the unit has been oriented, you can open the lever, insert the cables, and fully energize the single bolt. And then you can run in hole. And that's the end of my presentation. Thank you for your time, and I'm sure Bin and myself will be pleased to take any questions.
Thank you very, very much, John at TB. We encourage you all to put in their questions into the chat box, or you can raise up your hand and then we'll unmute you so that you can ask your question. I think we've got one question from Fifi. Yes.
The question is for me. Does this technology have any crack, embedded crack, or internal, external, semi-elliptical crack? The eddy current that I show you detect only cracks on internal surface. We still rely on NDT expert to do visual inspection for the crack on the external surface. There's one robot under development. It means that we have a prototype, but it's not commercialized, that detect volumetric defect. So using ultrasound. So it's a higher version of ultrasound in-pipe rover that detect all the internal, inside the wall or external surface. So volumetric defect, including lamination. Like if you have a thin layer of non-metal inside the body wall, it wouldn't be able to detect as well. I hope I answer your question.
Okay. Thank you very much. I don't know if Fifi, I don't know if you're okay with the answer. Okay. So I've also got a question.
Yeah.
It was interesting. It's interesting knowing the innovative things you've done. But then I also would like to know, does it apply to all pipe sizes in terms of the rover and as well as the pre-installed cable protector? Does it apply to all pipe sizes?
The rover that we have nowadays run in casing from 7 to 18 inch. Again, tubing size is under development, so we have prototype, but it's not released yet, and it runs from 5.5 to 7 inch only. The smaller it goes, the harder to go inside, and we think that for the small tubing, we go from the external approach, so we measure from the external body.
Okay.
For the cable protectors, at the moment we have units for 4.5 inch and 5.5 inch. They've been designed for VAM top because VAM is a Valorec product, so it's easier for us to use the VAM couplings. But the cable protector designs can be made to fit any coupling, whether it's Tenaris, JFE, or VAM. And we are currently looking at 3.5 inch versions, and we are considering other sizes as well. It very much depends on what operators or service companies require. If we could be given any details of jobs that are being considered, then we can review it and just let you know if we can quote or not. So.
That was great. And then I also like to know there's this interesting thing I think TB mentioned in regards to the rover. After detecting the information from the pipes, it's able to transmit it to the user or the operator, and then be able to make decisions, flagging some of the pipes that are old and has to be reused. I was wondering what sort of criteria will you use to be able to flag some of them as old, or does the operator have to input his criteria? Or so I don't know. Yeah.
Very good question. Thank you. There's no standard nowadays say about the criteria. Normally it's between the operator, so the owner of the pipe, and the inspector, so the owner of the rover robot, to agree, to discuss and agree on the criteria. For example, the case we have with the IOC in Brazil, we say we want the higher collapse rate than 13,500 PSI, but collapse depends on many factors. One of the key factors is the wall thickness, and we convert it into the criteria that is wall thickness higher than 90% of the nominal data. So that basically is a kind of criteria or number that we can agree, we can discuss and agree with operator. But sometimes we say, if the defect is 50 centimeter away from pipe end, we agree to cut and rethread. If it's 4 meters away, we will reject the pipe. Or if the defect is deeper than 5 millimeter, we will reject for sure, because the pipe, let's say 12 millimeter thickness, and if defect is already 5 millimeter, we cannot repair. But if it's like 1 millimeter deep, we can still do some work on it, then we will work on it. Otherwise, it should be scrapped. So again, the accept, reject criteria come from the operator, but of course with the consultant of the NDT expert.
Okay. I think that's very, very good. So that the operator will be able to specify the particular criteria to use. I think there was a request put into the chat. I don't know if that can be met. That the video I think that John shared, I don't know, with some of the participants were finding it difficult to actually have the video, watch it very well. So I don't know if John can share the video.
The video at the very end of the presentation is readily available online via YouTube or elsewhere. I will send a link for that. Some of the other videos are a bit large to share. I can do a shortened version of the presentation to PDF it to send out to everyone as a recap of what went on. So I'll do that, but there won't be any videos on that because the videos do make it a very large document, which is difficult to send.
You can go to YouTube, type prime mapping, tubular repurposing, pre-install cable client, or you can go to Google to type the same thing. Google Valorec prime mapping, Valorec tubular repurposing, Valorec pre-install cable client. Normally in the website of that solution, there is a brochure and probably some webcast and some video as well. Let me make an example. Let me share my screen and show you how to do it. So for example, if I'm in Google and I type Valorec prime mapping. So I have it here, Valorec prime mapping, and below is a video, okay? So in this page, you have the description, etc. But here, document and resources, where you have a leaflet, where you have a webcast, a replay, and the video. So you can find the information easily. Okay?
Okay, I think
While waiting for the next question, I just want to share with you the story of how do we make this development come true. Normally we have engineers like you working on the field, on completion, on drilling, on the connection, etc. So they think, oh, this is not optimal, we need to improve it. And they come back and they do like first prototype by plastic in the garage, and then they submit the idea and got called for investment. And we work with a different engineering company to develop that plastic prototype into the real robot. And our partners are everywhere, Brazil, in France, in Germany. So if people can do, you also can do, the young engineer in Ghana, if you have any ideas that you think that some operation is not good enough, we should improve it, please raise your voice, okay?
yeah, that really will do. That really will do. We've got just a few minutes to end the call, but then I've got a last question that I would like to ask. In terms of depth, does the rover have depth limitation in terms of transmission of data from the rover to the operator on the rig floor? Does it have depth limitation?
Like we said, we run on surface, so either in a yard or on the rig deck, not the rig floor. This equipment is not intrinsically safe to be run on the rig floor. So if you have a main deck that is large enough to insert the rover 2 meters at one pipe end, then we can do the measurement. And because it's already on the deck or in the yard, you can place the laptop very near, like 1-2 meters. So it's a normal Wi-Fi transmission limit, so a few meters. Not recommended for the rig floor.
Yeah, we'll definitely keep that in mind. Yeah. So the time is far gone for our call today, the arrangement. So we really thank you, TB and John, for making it to our technical session for this month. On behalf of our SPE Ghana chairperson, as well as the officers for SPE Ghana, we actually thank you for making it to this technical session for March. If this is your first time attending one of our technical sessions, for SPE Ghana, we organize technical sessions every month. And look out for next month's technical session. You see the flyers around us like you saw with this. The whole session is also being recorded and will be placed on our YouTube page. So look out for that as well. If you missed anything, you can reach them over there. I don't know if you'd be okay to share any your LinkedIn profile or email should anyone have any question to ask you. I mean, John and TV.
Absolutely, no problem. I'll do as I say, a PDF version of the presentation and issue that to yourself for distribution amongst your colleagues.
Same for me. And in the presentation, there's my email address, and also you can shoot any email to the Valorec contact on our website.
Right, that's very, very good. Okay, thank you all for making it today. We've actually had a very good, fruitful discussion. We've seen how to optimize casing and then tubing in terms of production, in terms of drilling and completion operations. We've seen how we can actually optimize them without putting a lot of people in danger, in a safe manner and in a time convenient manner as well. So thank you all once again for joining this month's technical session, and then we'll definitely meet again for next month's technical session. So
thank you for inviting us.
Yeah. Okay. So bye-bye.